In this video, we're going to look at some more examples with sine, cosine, and tangent ratios. When I first started seeing this stuff, it blew my mind. It seriously blew my mind. It might blow your mind a little bit, but hang in there, be patient with it. It's pretty cool what you can actually do with this. So let's remember that we have definitions for sine, cosine, and tangent as given on the screen. I want to focus on just maybe one or two of these in this video to keep it short. So let's take a look at a specific example below here. So I have a couple things. Here's a right triangle where I have the hypotenuse labeled as 15, okay, and I have one of the legs labeled as 5. Now, depending on whether I want to talk about angle A or angle B, remember C doesn't matter, then 5 has a different name. So if I choose angle B, I have purposefully now called the leg that's 5 the adjacent side. Okay. If I were to choose to talk about angle A, then the leg that's 5 would be called the opposite side. So now that I see the two sides labeled as adjacent and hypotenuse, then just to keep this without too much work here, I can just talk about the cosine of angle B. And cosine is defined as the adjacent side divided by the hypotenuse as a ratio. And it will, in this case, be 5 over 15, which simplifies to 1/3. All right, so we have that. Let's take a look at another example. In this case, I have a 30, 60, 90 triangle that we've talked about before, and I only have one of the legs labeled 6. So how could I do any of these trig ratios unless I have two sides? Well, since I know something about special right triangles, 30, 60, 90, I can exploit that. Remember, the hypotenuse is always double the shorter leg, and the shorter leg here is 6, so we would know that that is 12. So if I wanted to talk about the sine of the angle, instead of calling it A or B or C, I can actually refer to the angle. I can say the sine of the 30-degree angle would be equal to, or remember, sine is our opposite, right? So we've got opposite, 6 divided by our hypotenuse, 12, and we get 1/2. All right? So we can actually find the sine of 30-degree. Well, we can go a little further with this, and this is where it began to blow my mind, is you can actually figure out sine, cosine, or tangent values without any sides. What? Let's take a look. So let's remember let's take a look at that same 30, 60, 90 example. Well, what do we know about those? Well, we know they have a shorter side. I'm going to call it x. We know that the hypotenuse is always twice as big as x. And we know that the longer leg is always square root 3 times x. So if you were to look at the sine of 30 degrees, it actually always has that same answer. If you look at the sine of 30 degrees, what side is opposite it? X. What side is the hypotenuse? 2x. What happens when we simplify? Well, I can see the x's simplify to just be 1/2. Precisely the same answer. You still have a numerical answer, even though you didn't know any of the side lengths. And that would be true for the cosine as well and the tangent. If you wanted the cosine of 30 degrees, you would use the adjacent side to this. The side that's next to it is square root 3x. And the hypotenuse is 2x. And if you simplify it again, you would figure out that the cosine of 30 degrees is square root 3 over 2. Now, if you were to use a calculator, you could figure out exactly those values. And I want to demonstrate that briefly. Okay, here on my calculator, if I take the square root of 3, which is that, and then I divide it by 2, I get 0.866. And this is really ugly number, but I want you to remember that number, 0.866. Now, the calculator has also memorized these angle measures for every single, trig ratios for every angle. If I were to just type 30, yeah, like 30 degrees, and I were just to hit a cosine function button, it'll give me the same answer. So here on this calculator, it has a trigonometry tab. On a standard scientific calculator, there should be a button that says sine, cosine, or tangent with the abbreviations. I'm just going to choose the cosine button. Lo and behold, what does it say? 0.866. So that's the value of the calculator, is you don't have to go through all of the work to find the actual side lengths. The calculator has pre-memorized what those ratios are for any angle. All right. So cool. Even if it's something obscure, let me zoom out just a little bit here, like a 42-degree angle. We don't know anything about 42, 90, whatever triangles. We don't know the relationship, but the calculator has pre-memorized those. So if I wanted to know what the tangent of 42 degrees is, all right, rather than knowing specific examples like what is the opposite side? What is the adjacent side? I don't know. I don't have any side lengths. That's pre-memorized on the calculator. Okay, and they used to have these in table values in a book.